Hello everyone, welcome back. And today we are going to look at one of the most popular tool called Hashcat. So Hashcat pretends that it's the one of the most fastest hash cracking tool in the world. So today we are going to do a comparison video on Hashcat and my hash cracking tool which I have created, but right now it's still in the development phase and it only supports MD5 hash cracking. So the problem with Hashcat is that it requires GPU in order to crack the hashes, as you can see in the video. And but the thing is, it's free and it's the most powerful hash cracking tool, and it supports many algorithms, as you can see, many. So these are all the algorithms which are supported by Hashcat. And also it has many attack modes like straight, combination, brute force, dictionary, plus max, and etc. So today we are going to try Hashcat in our main machine and also in VirtualBox, and let's compare the performance of both Hashcat and my hash cracking tool, and let's see that is Hashcat really the world's most fastest hash cracking tool, or is it just bluffing. So I have taken a string which is butterfly, and now I'm going to use the string in order to crack the hash of it. So I have converted it to MD5 hash, and this is the command which is used by Hashcat in order to crack the hash. So the mode is 0, attack is first, and I have provided the raw queue dictionary. So it's starting, and it cracked the hash, and it took 4 seconds, 3 seconds in order to crack the hash. So 3 seconds was what Hashcat took in order to crack it. So now we are going to test in my tool. So my tool works on Python. I have created this tool on Python, so all that you require to run this tool is Python and a library which we'll talk about later. So here I can mention the number of threads that I will use in order to crack the hash. So this is something which is not available in Hashcat. You cannot mention the number of threads, and as you can see here, my tool took 3.17 seconds in order to crack the hash. So Hashcat also took 3 seconds, but Hashcat didn't mention the milliseconds there. So let's assume it's a draw, but let's say my tool is 7 seconds, 17 seconds backwards than Hashcat. Let us do another comparison and let's see what happens next. So I'm going to take the hash, first take the string and convert it to MD5 hash. Okay, it's June something. So I will copy the MD5 hash and let us do the same thing. I'm going to change the hash, and there we go. So it has started. So as you can see here, it took so it took 4 seconds in order to Hashcat to crack that hash. And let us try in my tool. So I'm going to change the hash and everything is going to remain the same. Okay, so but this time my tool took 6 seconds, which is 1 second less than Hashcat. So let us try to change the threads and let's see if we can compete with it. So this is the ability of my tool, that you can change threads, and now you can see it cracked the hash in 5 point something second. So the performance was increased after changing the threads. So this kind of functionality is not available in Hashcat. So let us try with 10 threads and let us see what's going to happen. So it's 5 point something, 5.74. Okay, so it was some milliseconds faster. Okay, so let us try to do something else. Let me go with 8 threads. So again it's 6 point something. So overall my tool is around 5 to 6 seconds It's taking the time, and Hashcat probably wins this battle. My tool was not even able to draw the battle with him this time. But anyways, not a problem. Let us try. Now we are going to see the Hashcat in Windows. So I have a virtual machine here, so I'm going to fire that up and let's check the performance in the virtual machine. How well can Hashcat work? So let me start the machine. So let us check the performance in this Windows machine and let's see how well can Hashcat work here. So till now my tool and Hashcat had a draw for the first hash, and in the second hash clearly Hashcat was the winner. And let us try in the virtual bomb machine and let's check how well can it work in a virtual environment, because see there are PCs which are low end. So these kind of PCs are these kind of PCs I'm simulating using the virtual machines because I have not allotted the full system resources in this virtual machine. I think I have given around 6 to 7 GB of RAM, and the CPU stays the same, but the thing here is that in this virtual machine GPU is not supported. And as we know that Hashcat works using GPU, so here Hashcat should not be able to work, and that is one of the most disadvantages. So people with no GPUs, what are they going to do, right? So it's not going to work there. But they say that there's a legacy version of Hashcat which can work without the GPU, but I have never tried it. But let's do a video on it someday. We will do a comparison on it as well, but here first let's try to crack the hash and let's see if it can crack it or not. So let me copy this MD5 hash. Okay, so as you can see here, that's the error that Hashcat is going to throw at you because there's no GPU, so it's not working. So about the legacy version, we are going to try it someday, but not today. So Hashcat barely failed at this test. Now let us try my tool in this virtual machine and let us see how fast can it crack the hash. So I'm going to provide the word list, and as you can see here it only requires Python to run, and then I'm going to provide the hash. Oops, sorry, I made a mistake. That's the hash. Let me copy the word list path and have the hash. Alright, so since this is VirtualBox, I'm going to use less threads because we don't want the machine to get overwhelmed. Okay, so it started. So as you can see here, it's taking a long time because it's a virtual machine. It's not a live, it's not the real machine. So you can see that it took 15 seconds in order to crack the hash. And on the B sides, you can see that dehashed, that is the dehashed thing of that hash. Let us try on Linux. So if we use Hashcat with Linux, we can use it without the GPU, and that's where the comparison can be done, right? But in the Windows, I need to download the legacy version, so that I'm not going to do in this comparison video. For that, I'll make a separate video someday. But since it's available in Linux, let us do from this Linux part. So my tool is not also installed in this machine, and neither Hashcat. So both we are going to install, and then we are going to see the dependency of both machines, and we are going to see the space required and everything. So first of all, I am going to copy my Hashcat, oh sorry, my MD5 cracking machines code, and okay. So after I copy that, now we are going to install Hashcat. So sudo apt install. It is going to take 959 MB in order to install the Hashcat, because there are many dependency of Hashcat. So it's a heavyweight application in terms of this, because you need the compiler and everything, and I think they have many libraries as well. So let us compare it with my tool now, and let me show you the space my tool is using. So it's using 8 KB. So 8 KB is the space that my tool is using, and it only requires Python. So Python, I think it's almost 50 MB or something while you download it, and after installing, I don't know, maybe 100 MB, 200 MB, and then you require a library which is term color, and that's it. Basically that's it. 8 KB my tool, Python around 30-40 KB to download, and after installing it's around 200 MB I guess, and then a library which is term color. So that's all required. So if I try to fire up my tool, this is going to throw me an error that no module is found named term color. So I'm going to install that now. Pip has alright, so the package is being installed. Okay. Okay, so now the package has installed. Now I'm going to try to fire up my tool, and as you can see here, with a single library it was able to load it, and no other library was required, right? So I think it's a win in this comparison, because the dependency are very less in my tool. So that is going to be a good advantage for my tool. So I'm going to get the rocku.txt file. Alright, so I have got the rocku.txt file, and I'm going to get the hash. So this time we are going to try with another hash. We're not going to use the same old hash. So I'm going to use this funky. Let me paste it, and we are going to mention the number of threads. Okay, it's a permission denied. Let me try sudo. Okay, so it's working now. Hmm. So let's see. Yeah, so it took 6 seconds in order for my tool to crack the hash. Let me try to increase threads. So we are using 4 threads now, and let's see. So now it's 5.60, so which is better. Now let us try with Hashcat. So Hashcat now here is only going to depend on the CPU and not the GPU, right? So let us test the speed. So here now Hashcat is only relying on the CPU and not the GPU. So this is the true performance of Hashcat, only using the CPU thing. So let us see how long will it take in order to crack it. So as you can see here, it's taking a little longer time. So it's probably longer than 6 seconds. So you can see here, in terms of CPU, only using the CPU my tool is way more faster than what Hashcat offers. But yes, Hashcat has many algorithms which are not in my tool. Hashcat can crack many algorithms. So you can see here the result took about a minute in order to crack it. So it was very slow in terms of only using the CPU. But yes, Hashcat supports many algorithms, so which is a great thing. So I'm going to also add other algorithms in my tool, and then finally make another comparison video on Hashcat and my tool. Thank you for watching.